Yes, one, two, three, four. Hello everyone. Today we discuss about the periodic trend in properties of elements. Here, that is the chemistry video lecture series. In this particular case, we have already discussed number of different topics which are related with the chemistry. So, chemistry itself is one of the large subject in which number of disciplines are there, including the science, engineering, technology, and daily life related matter as well as the medical science. So, all relevant science and technology itself is related with the chemistry. Chemistry concerned with the materials, the different materials are involved in various activities, even when we have also the very vital materials. So that is the concern of the chemicals. Now, different elements are available, and those are arranged in a table form, and those corresponds from the hydrogen atom to uranium, and after uranium are the trans uranium. So here, one more thing is there, that different atoms are arranged in their specific atomic number. Atomic number arrangement, and that clearly indicates that uh, there is the role of electron also, because when we have to see the number of protons, which are the atomic number. So positive charge particle protons having the equal number of electrons. So therefore, each atom having their positive charge as well as the negative charge. Positive charge particles are protons and negative charge particles are electrons. So that is concerned with the atomic structure, and I have already discussed. So all of you have to see the video lecture of atomic structure, in which one more, that is the development of atoms, atomic structure. So that is also mentioned in my good video lecture. So all of you have to see that. But I revise that atom, the different subparticles, protons, electrons, neutrons. Charges on the atom is the neutral. Inside the atom, two different charged particles, the proton one and another is the electron. So that is there, and here inside the atom, nucleus is present, and surrounding nucleus continuously electrons are moving in their respective atomic orbitals. That concern their atomic orbitals, their subcells, their shells. So that is all about the atom. Here, one more mention, I think all of you would know about that, the energy transformation. So different electrons moves from one atomic orbital to another, or whatever the one shell to another, that is more difficult. But they emits the radiation, so that is the spectrum emits radiation or absorb the radiation. So that is the concern of the spectrum. And spectrum concerned with the electromagnetic radiations. So energy, atom, electrons, all those are correlated with our advanced life as well as different technologies. Even in case of the space research, there is also the involvement of the charge, whatever the electron, whatever the proton, whatever the different atoms. So now we have here the periodic table, modern periodic table, that explains that there are different periods are available, and what we have to see that different periods available having the period. number systematic arrangement, period number 1, 2, 3, 4, 5, 6, 7. So from left to right, there are the periodic table, periods table having the number of periods. Here, from top to bottom are their respective groups. So what happened here? The systematic arrangement of elements, and this based on the atomic number. Whatever atomic number is equal to number of protons, or because the protons having the positive charge, so equal number of electrons are also there, so that is also the number of electrons. Now here, what we have, the space after a specific period, the element go to their groups. So, what about the groups having there? The most of the properties are similar, as well as the electronic configuration, that having the general electronic configuration. So, for example, alkali metals. So, in case of the alkali metal, the general electronic configuration is Ns1. So, N is equal to the number of period. So, whatever 1s1, 2s1, 3s1, so like that particular group. So, how this particular system arranged? Because when we have to see, this all came from the nature. We have don't touch that particular matter, that this atom must be remain here, because the different properties are available, and then the different properties are of the atoms. Now they reoccur at the same in the same group. Earlier, this was thought that this groups was related with the atomic weight. But now the modern periodic table itself explains that the arrangement is based on the atomic number. So systematic arrangement is there because earlier in 19th century there were no invention of so many elements. So further we those elements when invented, then further. So now at this moment there is the complete periodic table starting from the 1 atomic number to 92. However, above 92 are the trans-uranium elements. So that's how whatever those are also here, the synthesize some elements, and we have the perspective about that element will be of that because of the atomic number arrangement and periodic. Now, electronic configuration, that is the well known, whatever that particular electronic configuration. So, we have already discussed this video lecture in the electronic configuration of elements. So, now one more thing is there, and that is that how electrons are arranged. That is also very specified in their respective orbits. And one more thing is there, where is the electron present? So here the electrons are present in their respective respective orbitals. But how we can define that particular electron is present in that particular atomic orbital? So how we can say? So for that purpose, we have the electronic configuration of atoms, of elements. Here, the arrangement of electron, that is the configuration. So how they configured. One more thing is there, and thus all those are related with the above principle. One thing, then there also because of the quantum number n plus cell rule, and one more Pauli's exclusion principle, and one more is the Hund's rules of multiplicity. So the above principle explains that which the electron goes to which atomic orbital. So that can be explained in the Habau principle, and according to that, we get the energy systems. So, therefore, where electron goes, one thing is there, and that already, but we have the 1s atomic orbital, 1s a subcell, whatever that. Then second, so 2s atomic orbital, 2s subcell. Then we have the 2p. So then 2p having the three atomic orbitals. Those are the 2px, 2py, and 2pz. So that is the system electronic configuration of different elements. Now we have to come towards the next part, and that particular we have to see uh, the periodicity and periods and groups and metals and metalloid, non-metals, heavy metals, light metals and active metals, the passive. Whatever the periodicity occurring, the properties of when we have to continue addition of the electrons as per the electronic configuration, then and then some after certain period, whatever that, if suppose we have the time, then definitely we get after 24 hours again new days. So similar to that, some periods after certain period, the element goes to that particular group. So, for example, in case of the alkali metal, if we continuously add the element, the electrons, for example, from the sodium, so continuously we are adding the electrons. Then after certain period, whatever the atomic number of sodium is 11. So after 8 electrons, whatever that atomic number, we get the atomic number 19. The number of electrons are the 19, 19. So here we get that after that certain period, sodium having the potassium. So sodium and potassium both are the alkali metals. So that is the periodicity. After so periods, whatever we have already discussed, the here explain the shell number, and those are the period, and number for periods are 1, 2. So that explain the first period, the second period, then third period. Then we have one more thing is there, and that is the very systematic arrangement of the period itself is there. So now, and the number of elements are also concerned in that respective periods. For example, in group number one, in period number one, only two electrons are there. So why two electrons are there? That is the electronic configuration system. That is the above principle. So in case of the period number two, how many elements are present in period number two? That is the 8 elements are present, and represents the shell number 2, represents the second period, represents the subshell. Subshells are the S subshell in case of the second period, where the P subshell. So here P S subshell having one atomic orbital. From the P subshell, uh, from P subshell we have the three atomic orbitals, whatever those are, the px, py, p, and pj. So let's we have to discuss about that how the periods are formed, and then the similar property elements, and those are the groups. So grouping, whatever the groups, any of the group, alkali metal group, halogen group, that is the oxygen group, that is the boron family. What those are also called the family because of the family member. So any of the person concerned with the family member. So similar to that, any of the element concerned with their respective group or the family. So alkaline earth metal, this one, this group number two, in the based on the modern periodic table. However, earlier the alkaline earth metal having the second A group, second A, but modern periodic table that is giving the numbering is from the 1, 2, 3, 4, 5 up to 18. So 18 groups are there. So now we have the heavy metals, for example, lead and tungsten, what was the rhenium, very heavy metals are also there. So therefore, they also relate with the different technologies and different available. So now we have to come towards the light metal. Those are light in weight. And then we have the activeness of the metal. Alkali metals which are more and more reactive. So also the active, when we have to put the sodium in open atmosphere, so definitely this will react easily and fastly with the oxygen and with the moisture present in the air. So therefore those are the active metals. If suppose we have the gold, that is well known for the human being, that is used precious metal, and that can be also used in different activities, but that is the passive. So why, if in presence of oxygen and moisture, this does not uh, react with the environmental things. So that is, those are the passive metals. So now we have to come another. We have discussed the different metals as well as the metalloids and the known metals also. Boron, carbon are the known metals, whereas the in between the metals and metalloids, those are the metalloids. Now, here the different properties of arrangement, and those relates with the whatever the electronic configuration of elements. Here the electronic configuration, we have to see the that is regarding the boron and nitrogen, carbon, nitrogen, and then oxygen, and then chlorine, and lastly the neon. So in case of the boron, whatever the atomic number 5, atomic number 6, in case of the carbon, and then atomic number 7 in case of the nitrogen. So all those are arranged here, can say. So how these electrons are filled, we have to concern about the nitrogen. So therefore, we can easily see in here the 7 electrons, which the arrangement. So in this particular arrangement, electrons are filled in respective atomic order. In case of the oxygen, so that is like this. So nitrogen, oxygen, fluorine, and neon. So their specific periodic properties are involved, and we have to go from left to right. So here two ways are there in atomic properties and their periodicity of those particular properties. For example, ionization potential. This is also one of the great property of the elements. And here we can explain on the basis of the this property that certain metals are active and certain are non-active. What are the passive characteristics? And but so that can be explained, and here because of their the electronic configuration, because of their the, so here from top to down we have the similar properties. Here I have taken the example of the ionization energy. Even we can more regarding the atomic size as well as the atomic size, that will be the radii, atomic size or the radii concern. So now we have to see, if suppose electrons are added because of the electron affinity, because of the electron the ionization potential, that can also relates, that relates with the how cations are formed. So let's we have the different periodicity in different properties. Mainly, what are the properties? The first one, atomic size, one thing. So that is the also the most important properties. Then second one itself is the ionization potential, ionization energy, or the enthalpy of ionization. So because of the ionization potential, cations are formed because electrons are lost. So how we can say that electrons are lost? Anyone? Because here so many answers are there, but most important one is the electronic configuration. So what we have to see, Here, the different atomic electronic configuration of first group, and let's we have the neon, that is the more stable electronic configuration, and that one can be explained based on the available electronic configuration. So that is the satisfied whatever the neon, and so that's why these are the inert gas configuration. So now we have to, before that, we can see the different periods here. We have already discussed about the second period, and we have the third period here, the 3S, then 3D. Whatever. In case of the third period, sodium, magnesium, aluminium, silicon, phosphorus, and sulfur, and then chlorine and argon. Okay. Now we have the fourth period here, the 4s, the D 4s, where the 4s1, 4s2. Now the electrons moves to 3D. So in case of the 3D shell, 3D different atomic orbitals, here the electrons are filled. So from the scandium, titanium, vanadium, chromium, manganese, cobalt, nickel, copper, and zinc. And then further in fourth period, the electrons are entered in the p atomic orbital. So the greenish shade is itself is of the p block element, and yellowish itself explains the d elements, whatever the particular the transition element, transition metals called, because the most of the are the metallic behavior. So now here also the bottom, and those are the concern of the F block elements. Here all of you can see. So here the cerium, then praseodymium, neodymium. So lastly we get the uranium. So now this is systematic arrangement of the modern periodic of elements, and this particular is what we have. This is based on the specifically electrons, and electrons have also gives the different, definitely different properties. Here 18 groups and 7 periods. Now if suppose we have to see the electrons are added in case of the period number 2, so what will be the atomic size? One more thing is there, what will be the atomic radii, and what will be the ionic size and ionic radii? Here in this particular case, if we have to, lastly, that is the fluorine. So in case of the fluorine, one electron is added. So why one electron is added? Whereas in lithium, one electron is lost. So the different properties, including atomic size, the ionization potential, and because of the ionization potential, we can explain that particular element is electropositive element. And then we have the electron affinity. So for that purpose, we can say that particular element is electronegative. And electronegative elements, then we have more and more relevant are the electronegativity of the element. So now we can say the whatever the different properties, and there uh, one more thing is there. These four properties are the atomic size, one thing, what was the diameter, and then atomic radii. Here, the nucleus, and surrounding the nucleus are the orbits. Those orbits are of specific orbits and atomic orbital. Atomic orbital, the space where maximum probability of electron is there, whatever that, because electron continuously moving. So therefore, that is the only space, that is the probability that in this area the electrons are present. So that is atomic orbital. So now we can continue for that, and already discuss number of elements which covered, and now we have the this one arrangement. So what we have, we can see the properties of atom. Ionization energy from left to right, one thing. The atomic radius from top to bottom. The non-metallic character from the left to right. Then metallic character here, this one from right to left. In case of the electron affinity, that from bottom to top. Then ionization energy, that from the bottom to top. So here the most important whatever we can discuss, the four things are most relevant: ionization energy, electron affinity, and electron affinity and ionization energy both, as well as the third one is the whatever the electronegativity. So electronegativity, electron affinity, ionization energy or ionization potential. So lastly we have the four one, ionization energy, electron affinity, two ways. Then we have the electronegativity, that is the third way. And fourth itself is the atomic size. So these properties vary in the respective period as well as in their respective groups. So whatever more thing is also because of those properties, some other properties also derived. So for example, non-metallic characters. So whatever in case of the p block elements, you can see that periodic table, that p block elements and as well as the d block element. So the atomic radii differs, and why that differs, and from this from left from right to uh, the left, that is the relationship of the atomic radii. So from right to left, we can see the atomic radii are increased, the metallic characters are also increased. So why? Because of the electronic configuration, because of the available electron in that particular atom. Now we can say the electron affinity from top to bottom, or from bottom to top. In case of the ionization energy, that is electropositive. Electron affinity, that is related with the electronegative. So electropositive concerned with the ionization energy. So from this from down to upward. So that's we have see a different relationship, and that is correlates and here the electronic configuration is one of the important concern regarding the nitrogen, oxygen, fluorine, neon. Here one more thing relationship, and that is the relationship how electrons are filled and then electronegativity are increased. So here the increase from the bottom to above, and then the this one is also related with the decrease. So we can say from diagonal relationship, also from the radium to the chlorine. So here, whatever we can say, the electronegativity itself is relates with the electron pair that is available in the bond. So that is the attraction of those electrons and in their respective valence bonding. So one more thing is there. Here we can say electronegativity itself is to attract the electron in their the electron pair. So that is the valence bonding. Valence in that particular case, valence electron undergo the process of the bonding and that type of bonding is the valence bonding. So that is also I have in one of the video lecture where the chemical bonds and those are the ionic bonds and as well as the valence bonding. That is the covalent bonding. So covalent bonds are formed because of the sharing of electron. But if suppose the sharing of electron and electron pair is formed, so A and B. So in between those, the covalent bond is there. So that particular electron bond is attracted towards one matter, one element. So that particular property is the electronegativity. So when we see the whole of the uh, periodic table from, we can say from bottom to the top, and or we can inverse it, but from bottom to top, the electronegativity is increased. Whereas from left to right, that is also increased. This particular case, with whatever the whole periodic table, then diagonal starting from the whatever the last in case of the period number 7, there are the francium, then the radium. So from radium, then there will be a sharp diagonal piece. So that is we get the particular chlorine and then the fluorine. So most one chlorine having the 3.5, whereas the fluorine having the 4.0 electronet. Whereas when we have to see the hydrogen, then the lithium, so those are the 2.1. In case of the second period, we start from the lithium, sodium, here the boron, and then we can take the carbon. So carbon having the 2.5. So covalent bonds concerned with the electronegativity property, and by which the polarity or partial charge is shifted. So because of that particular partial charge is appears because of the electronegativity difference. So electronegativity property is also the most one in different elements. Now we can say if those are the system and so that is specific, very specific. Whatever in case of they are the different groups and from group number 1 to 18. What about the group number 18 electronegativity? In this particular case, the group number 18, which one is the inert gas generally? So those are the noble gases also. So here, because of the outer shell electrons are 8, so that is octet rule. So they are stable. However, there are the various examples of the compounds also. So in this particular the period table, special the ionization energy is mentioned. Now we can again the another property whatever we have discussed the direction of increasing electron, that one also explained from the Francium whatever we have earlier discussed, and that particular we have the second period, the first period. In case of the second period, fluorine. So what about the helium, neon, argon, and krypton, and xenon, and randon, and whatever the UNO? Here, when these are the stable uh, and noble gas configuration, this one is also mentioned. So lastly is attained up to the fluorine, that is the 4.0. So similarly, there are the other properties are also there of different and those are the electron affinity as well as the concern of the ionization energy, and we already discussed about the atomic uh, atomic size. So here the atomic size, atomic radii, the ionization energy, then the electron affinity, and because of that other properties appears. What are those other properties appears? For example, the density. So density also correlates basing on all those the different properties of whatever. For example, then metallic character. So metallic character also can be corresponds with the electronic configuration. So and those are also related with the specific gravity. So various properties, whatever the physical properties, even the most of the chemical properties. Chemical properties are also related with the properties of atom, because when we have to see if ionic compound formation, in case of the ionic compound formation, which elements are which elements form the ionic compound. The example is well known, electropositive element and as well as the electronegative element. So that's if suppose we take electropositive sodium and electronegative element from the chlorine. So both have the characteristics and formation of the sodium chloride, that is the table salt. So why that particular property appears? Because of the ionization energy, so ionization energy, and because of the whatever the electron affinity. So here we can say that electron affinity is more and more in case of the chlorine, whereas the electron affinity in case of the sodium is less. Similarly, ionization energy, that is less and more in case of the chlorine. So here the low ionization energy of sodium, and that can easily gives the answer that sodium can form the cation. So that's from where we get the information. That is the periodicity in different properties. Whereas in case of the chlorine, chlorine does not have, because of the high ionization energy, so chlorine does not form the chlorine cation. So what we have, the whole different characteristics. Major one are the four: whatever the atomic size, whatever the ionization energy, whatever the electron affinity, and whatever the most one also, that is the electronegativity. So all these uh, four properties, atoms properties explain so many things. Whatever the hydrogen bonding, this can be explained. Whatever the liquid state, so many properties are. If anyone can say the oxide formation, so which elements form the oxide, so that easily explained based on the atomic properties. So here all of these, and then we have the most important one, the electronic configuration. Whatever in case of the nitrogen, that can be explained that there are the five electrons present in the outer shell. So definitely we can say if a specific compound ammonia, so that can be explained easily based on the, so why ammonia itself is gas, then we can say the oxygen, in case of the oxygen, the hydrogen atom, so H2. So why H2 is the liquid and NH3 is in the gaseous form. Then we have the fluorine. So in case of the HF, hydrogen, we can say, so HF itself is the hydrofluoric acid. So that's the behavior is chill. So different properties are also relevant with the electronic configuration. H2O, that is the water, NH3, that is the gas, and HF, that is the strong acid, whatever that particular concern. So why water is not acid, and why an NH3 is not a liquid? So all these particular answers are also correlates those based on their the atomic size, atomic ionization potential, ionization energy, and electron affinity, and then the electronegativity. So this is one of the great concern So that we have the multiple choice question. The when N2O, correct answer, this is acid, N2O is called the laughing gas. So is the euphoric effect after being inhaled. It is one of the World Health Organization's essential medicine. It is used for the recreational and anesthetic purpose mostly. Recreation and whatever anesthetic purposes. Now, whatever we have already discussed about the ionization energy, so we can say that particular ionization energy itself can be correlated, and we get the answer that particular the ionization energy are always positive. So now we can say